Our next talk is by Fredrik, and it's about remote execution with Buildbarn.
Yeah, let's see. Yeah, I'm Fredrik Medley, working for a company called Marathon. We are consulting, helping companies set up a Buildbarn and convert to use Bazel. So Buildbarn in brief, it's a remote caching, remote execution system that's optimized for very large clusters. Was created 2018 by Ed Schouten, and it's free open source, has been adopted by many multinational corporations. So I will try to show you how it looks like if you with the configuration if you set it up. So let's start easy with, we have one storage place. We put all the cache entries in that storage, right to local disk, and the Bazel client connects to that. Pretty simple, but the storage gets full, so we need to shard. Then we add the front end to put certain cache or certain blobs in the different disk storages there. That is based on the hash of the blob, so the front end knows exactly which shard to go to. After this, you can see also here to the left that all the configuration is written in JSON.NET, and all the documentation about these configurations are stored in the proto files in the repositories, and there are also default values. These are important to read because 0 is not a good value to use, which happens if you don't mention anything in your configuration. We also add redundancy. Mirroring is a good one, and you see the configuration grows a bit. Now, load balancing. If you have 3 storage nodes, maybe your front end can't cope with the load. So let's just add let's scale the stateless front end very easy in Kubernetes if you use that. Now, we have multiple offices, so it's good to have an office cache to reduce latency. So let's have the central cluster somewhere in the cloud, and then let's add an office cluster with the front end and the local storage there. And then you get a read caching with a fast office storage and a slow central cluster connection. That's not really good if the local storage goes down. So therefore we have a read caching, and then we have a read canarying to say that if the storage in your local office is broken, then just go to the central storage instead. It will add a bit of latency, but that's all right while the local storage is down. You can, of course, configure with mirroring in the office storage as well if you want, but depends on your needs. On top of this, when you look for action results, so checking for cache hit in Bazel, the get action results message, when you respond to that and say, I have a cache hit, then Bazel expects that all the blobs are actually located and you can read them from the storage. But we don't need to transfer all of the blobs when we do build without the bytes. So therefore, we add an existence caching part on the local disk so that we don't have to ask the central cluster if all these blobs exist all the time. And that will speed up all the cache hit checks a lot. If you want even more caching, you can add BB client D. That there was a talk yesterday about remote output service, and there you can add BB client D on your own workstation. So when you build something from different workspaces on your own machine, then you can use that local cache instead. Then we have remote execution, of course. So let's add a scheduler and worker and runner process. The runner process is less privileged. It might not even have network access, which is good for some actions. The worker is the one that is responsible for populating the disk with all the input files. And then there's a single scheduler, and it is able to cope with very big clusters, even if it's a single process. If we get a failure, you probably want to know why. And in the Bazel CLI, you get a link, so you can click on that link, but then you need the browser, of course. And so add that as well to your deployment. You might also want to log what has been executed, and log that to your database. So connect the action logger or use a completed action logging API to collect that data, put it in a database so you can search for example, very slow builds or reoccurring builds and what is the most costly computations that you do. And in the office, you might also have your own hardware or something else, so you need to add workers there as well. Well, that's also possible to add and configure. And those can then talk to the office cluster frontend, so to get the data delivery to those local workers a bit quicker. For the error handling, Buildbarn is just pushing all the errors back to the Bazel client. And there's a reason behind this. Say if a worker fails down at the bottom and a long-running test restarts, then you don't want to know that my test has been running for 20 minutes. Well, I expected it to finish after 12, and why is it now running for 20 minutes? Instead, the error is propagated back to Bazel saying, something failed. Well, you can decide if you want to retry or not. And well, as any of these links in the whole graph here can fail. It can be the first connection to the front end, so it doesn't really, if we do stuff again in the cluster, it doesn't help if the first link fails. So therefore, we ship all the errors back to the Bazel client so that you get informed of what is happening in the cluster, and Bazel can take the decision, should I retry or not? Then there are some extra interesting features, like I call it sticky scheduling. So if a worker has done some invocation, the output files are available on that worker. Then it's pretty smart if you can run the next action on that same worker, if there's a space available. So Buildbarn is trying to schedule all the actions in your invocation on the same worker. Well, if there's space, otherwise it uses more worker nodes. And thereby you get this locality of the storage, and it goes quicker. There's also a feature, sometimes some actions need extra memory or extra CPU. Well, if I want 8 gigabytes of RAM on 8 gigabytes of memory on my action, I will never reduce that again. I will never notice that I improved my action and I now only need 2 gigabytes of RAM. So you will always just increase the need of resources if you put that in a build Bazel file. But Buildbarn instead automatically can find out in the cluster saying, well, these actions seem to fail on a small node, so let's run them on a bigger node. And thereby it automatically, it recalls what size of node it needs and then puts out the action on that size the next time it runs. Then we have file system handling. So on the worker, if you use the Fuse or virtual file system, either Fuse on Linux or NFS on macOS, then Buildbarn will serve the files when you need them on demand. That means that your action starts running immediately, but you load the files when you actually read them. There's even a function where it logs what files you have accessed for a certain action. And then the next time you run a similar action, it will start to pre-fetch all those files. And there's kind of a race between, will your action need them before they have been collected, or will you have to wait when they are getting populated for you? Then we have monitoring, Prometheus, Grafana boards, OpenTelemetry, Jaeger, and then the completed action logger API, as I mentioned before, that you can hook into. Some frequent questions we get in the Slack community is, why is my storage slow? The usual answer is, you are layering your storage some way. So basically, if you have your remote cache on a network disk, that will be slow. Put it on your own, where you run the cache. Put it on a local disk there, then it gets faster. And use a raw block device and avoid layering VM on top of Docker or the other way around. avoid as many layers as possible, and then it will get fast. Don't forget completeness checking on action cache and existence caching on the content addressable storage. And for documentation, as I said in the beginning, look in the proto files. There are default values. They are really good. So in summary, Buildbarn is a free open source project available on GitHub. There's a Slack channel. Please use that. Professional services are available, not just by us. So look on in GitHub and see who are available to support you in setting it up. Well, it's a very flexible microservice architecture, and it's built to scale. There are clusters I know about using 100,000 vCPUs, and well, use the components that you like. Connect it to other things like base or remote or some other caching system if that is what you use today. Patches are welcome. Thank you.